Hello, everybody, and welcome to today's Voltha TST call. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So please be mindful of the comments you make and the information you share with the group. First of all, today I want to discuss the 2.7 release, which it's targeted for today. The release is looking pretty good. We have just a few things in Jira that are still pending. One is the documentation, a couple of others related to the Helm charts. That's the last thing we tag, and we're going to work through those during today and get them out. There's still a few releases of items that need to be made. The Voltha Onos image is not yet tagged. Some of the Onos apps, especially the BNG and Kafka app, are not yet tagged. There's a small documentation update that needs to be done in the OpenONU Go adapter, and that still needs a tag and an update. So that's what we're gonna do. Also, the Voltha Helm charts is not yet tagged, and the Voltha Infra and Voltha Stack charts are not yet tagged, but everything is ready. The tests look pretty good. So we are fine with 2.8. The release date is either tonight Pacific time or tomorrow morning European time, but we met the target of end of March. That's good. So that's a really good accomplishment, and I want to personally thank everybody for that. Before I move over, are there any comments, questions on the 2.7 release that you guys want to bring up? No? Okay, then if not, the second topic of the day is the discussion for moving from Kafka for the inter-adapter communication to Grpc. That's going to be hosted by Ken. He did some initial work and proof of concept for that. Before we go there, I have to drop at the mid hour because I have to go for the prep of the SIBA RD webinar. So if you don't hear from me, Matteo is gonna just take over the finishing up the meeting at the end. If I don't get the chance, given I have discussed this with Ken, the substitution of Kafka in favor of Grpc, to me, and I know I'm going to prevent some discussion here, but before I have to drop and I cannot give you my opinion, this is not of the highest priority, in the sense that yes, there are some really good performance announcements, I think. It's just that at this point in time, before we cut an LTS release, I do not think that we will go ahead and move over from Kafka to Grpc. Most likely the LTS release is going to be 2.8 at the end of June. We're going to talk about more about that next week. But this is just my opinion. I don't want to start a discussion right now. Let's see Ken's presentation, and then we can discuss that and also have it for a next time for maybe a final decision on that. Ken, you want to take over presenting rights?
Yeah, sure. Thanks for that intro.
I mean that it was just my personal opinion.
I know. I'm just kidding. No problem. It shows. Are you still sharing? Can you stop sharing?
Yeah, I'll stop sharing.
Oh, okay.
There you go.
Okay, let me see which desktop. This one. Okay, can you see this beautiful rock?
Yes, we can.
It's an island.
Yeah, it's very sunny there, but that's not my island. So So what I'm going to do is, originally what I wanted is just to show a demo of the Kafka to gRPC. Then I realized that the demo itself, like I'll show the demo, but a lot of the things is kind of in between the containers, between the core and the adapters and between the adapters. So to make more sense, to limit the demo time and show more the highlights, the code highlights, really the differences within them. So let me go over, basically I have a presentation here. I'm going to switch between presentation and demo mode and code mode as well. So can you all see this, or I should go to presentation mode? Maybe I'll go just to, okay. So like I said, I'll show an overview, I'll give a brief demo, and I showed some highlights of the changes, and also show some of the common patterns once we're going to use gRPC. There's a change from how we're using the Kafka before to the way we're going to use gRPC, and also what's next. So currently, how do we communicate over Kafka? Like here's an example, like between the core and the adapters. We have the Kafka messaging bus in between, and we have all those proxies. For example, from the core, we have an adapter proxy that talk to a Kafka proxy that goes on the Kafka, and on the, for example, if we're sending a message to the OLT adapter, the proxy on the adapter side will have to unmarsh all those messages, send it to our handler, and finally it reach its final destination, the RPC that's actually going to execute that code. So there is a lot of marshalling and marshalling of data in order to process things over Kafka. And here is just an example of how those things work. Like in the green line, you'll see that here the core is making an API call and to the proxy. But what the proxy does, it sends a message over a specific topic to the adapter and listen to a separate topic from the adapter for the response. So there is a lot of listening on one place and sending on the other place, and the same thing, like if two adapters have to communicate among each other, supposedly when your adapter wants to send proxy a message to the OLT adapter, it does the same thing. It sends it to the Kafka proxy, and on the Kafka proxy, it's again have two channels, one to send and one to receive, and then on the other side also. So there's a lot of complexity that goes behind the scene, and that adds to performance and make the code quite complex. If we move to gRPC, in gRPC, what we'll have is we'll have the Voltha core, we have a gRPC server, and we have gRPC clients. The same pattern is in the, I call it the parent adapter, that's an OLT adapter, and the child adapter, that can be any ONU adapters. So basically, like if the core wants to talk to an adapter, it has a gRPC client and talk directly to the server that is hosted by the adapter. And similarly, if the adapter wants to talk to the core, it uses one of its clients and talk directly to the core. So there is, other than the regular marshalling of gRPC messages, there's no those additional marshalling and marshalling that happen. And more so between the parent adapter and child adapter. Currently, what we have is we have only one message between the parent and the parent adapter and the child adapter. It's an inter-adapter message. It's a generic message that encapsulates a lot of small APIs within that, for example, like a deleted T count or a new indication. But it all goes over this single message, this single, in a way, API. And there is a lot of further marshalling and marshalling between them. But once we move to gRPC, then those individual sub-messages become like a gRPC API, each one of them. So they get called directly instead of having to be marshal and then marshal and then put inside another messages. And then, so there's much more complexity that gRPC helps us to resolve. And you will see a lot of that in the, when I go through the code highlights, it will be much easier. So in order to set up for the demo, what I'm going to, so what's the setup? Currently, I have just a single node environment. I'm using micro Kubernetes. It kind of seems to work all right. And I have a custom Helm deployment. Basically, it's based on the current Helm charts. I had to update it in order to put additional services in place and additional parameters in that one. In terms of the core, it's a custom image. It's built on top of the latest read-write core. It's I say Voltha release 2.7. Basically, it's code that was there since last Thursday. So I think this is the latest. It's the same for OpenOLT. It's a custom image. It's built on the latest OpenOLT code, and the same for OpenONU Go. And that's built on the latest one as well. So I don't know if there has been any additional changes that have gone into OpenONU code base since last Friday, I believe, Thursday or Friday. Then if not, that's whatever is here is the latest code base, except it has gRPC on top of it. And in terms of the other component that I'm using is like OF agent, Voltha, Onos. I'm using the images that exist today. So there's no custom images. Basically what it means is all those read-write core, OpenOLT, OpenONU Go are using a different proto versions compared to the OF agent and the rest, and it just works. So let's go to, let me switch screen here. Can you all see this screen? Is it big enough?
Yes.
Okay. So what I'm going to, well, I was executing something earlier, so let me clean that up. So I'm cleaning up all the infrastructure and all the Voltha deployment and BBSIM deployment that I had. I'm just waiting for everything to be cleaned up. Almost there. Okay, so first thing first, I'm going to install the infrastructure, meaning Onos and company. You'll see like in the window below, it has Kafka, Zookeeper, etcd, Onos being started. I'll also start BBSIM. And I will start the core, let me start that and then I'll go over this. So here I'm starting the Voltha core, the OpenONU and OpenOLT. Basically what it's a custom, like you can see, like I'm pointing to my own local Voltha Helm charts. It's a custom Voltha stack. I'm giving it my own image for core, and you see another image for OpenOLT and another image for OpenONU. The only thing that I'm providing here for the OpenOLT, I'm telling it where to find the endpoint of the core. So I set the core endpoint there, and I said also to the OpenONU where to find the core endpoint. The reason why I give them the core endpoint because the adapters have to register to the core. So for them to register to the core, they need to know where to find the core. So that's why I provide them with those tags. And everything seems to be up and running. Let me make sure that I don't have old port forwarding. I just have this. I'm just killing any port forwarding that I had before, and I'm just going. I have some shortcut here, so it's. This is just enable all the port forwarding. So let me see what version are we running of Voltha. And V here stands for Voltha. I just it's slow typo. I put everything as alias. So the Voltha version here is 1.5. This is what's released. And the cluster here is 2.8. This is what the Voltha Go, the version of Voltha Go. I didn't change the version when I rebased my code. So this is what it's based on that. The code is based on that one. And this is like, if we look at the config. The config is just like really the standard config. There's no changes there. And if I go to the list of adapters, should do adapter list, everything looks pretty much the same as before. The only difference here is when you look at endpoint, this is the service endpoint for the OLT adapter, and this is service endpoint for the ONU adapter. And you can see like the version that those adapters are using. Again, I didn't change the version per se. I just rebased my code on top of the existing version, so it's showing what version is out there. And then the last one is the last time it was communicated. There was a communication between the core and those adapters. So every time there is any communication that is happening from the core to the adapter, this last communication here get updated. And also there is an automatic heartbeat that happen. And I believe at this time it's every 60 seconds, it's configurable so that it monitors that connection. So if that connection goes down, it will automatically try to regenerate that connection. And since that code is in the Voltha libgo, all the components, the moment they are using that client, they benefit from that. So there is this automatic reconnect, and there's other functionalities there. I'll show later. So if I do it again, you see like, well, now you see 6 seconds. It means like there has been a heartbeat that has happened, and that's why it has updated that time. So let's create some devices. So let's do that, and let's enable the device. If you look at the device list here, so we have an OpenOLT and an OpenONU device. They are all enable, active, reachable, and the ONU is at the OMCI flow pushed. I mean, so that's the state that we want it to be. If we look at the other thing, like if we look at ports, for example, on the how many ports we have on the OpenOLT, well, we have the 2 ports there that was configured. If we look at the number of ports, on the ports on the ONU, we have those 4 ports, but only one is there's the spawn port active and the uni port that is active. And we can also look at the logical device. So we have that one. We can also look at the flows. So you have all those flows there, and also there's flows on the devices as well. If you look at the flows on the, let's say, on the ONU, you see there's flows there. And we can also go to ONOS and look at what view from ONOS devices. You see like it's there. See the ports there, and you can see all the flows the state are added, means they have all been pushed. And what else? What we can see? You can see. Well, I'm just show briefly the log, so you have an idea of. Those are again some shortcut command that I have. If you look at the log in the Voltha, for example, see those are all the stats that it has. You see this message. So we are still like for event proxy. So when we're proxying event to Kafka, we're still sending event to. We still have a Kafka instance out there where we're pushing events. So that's still applicable. So that hasn't gone away. You can see like it's successfully sent to Kafka. It's only the communication between the core and the adapters. That's all gRPC. And you can see one thing that I wanted to show you. For example, you see this. It's there's a heartbeat that happens. So if the idle timeout means there has been no messages exchanged between, in this case, between the OLT adapter and ONU adapter for a period of 60 seconds. That's what's configurable at this time. So it automatically checks the connection there. And it does the same thing with the core somewhere. Let's see if I can find it somewhere. Well, here you can see like it does the same thing with the core to make sure it's that connection is up and running. And if the connection is down, it will automatically tear it down and rebuild another connection. So that's all in the library. That's taken care of for you. And come on. And it's the same thing in the open ONU adapter. They're all using the same library, but the open ONU adapter is a little bit more chatty. So it's times, well, you can see here also it's it has this update, this idle timeout. Oops. Let's see here. Where was that? Well, sending to Kafka. Okay, don't go too fast. So you can see it's updating the activity with OpenONU. So it's trying to have this heartbeat in place. And here you can see it's exchanging OMCI messages and all those things. So let me see what else. What else we can see?
Ken, I have a question.
Yes. Yeah.
How the ONU adapter and the OL2 adapter knows each other's endpoints?
Okay, so the way it, maybe you can hold on to that question because I'm going to show some highlights, so it will be easier to show in code than just talking.
Okay, I was keeping myself not to ask, but I couldn't resist.
No, please. It is. I was expecting that question actually.
Okay.
Yeah. That's why I wanted to focus more on the highlights and in the code. It makes things a little bit simpler.
Okay.
So here we have that one. So what I'm going to do, I'm just going to delete the device here and get rid of it. And instead of doing more, oops. So instead of, okay, it's all gone. So instead of just going ahead and just show more things, because all those things is like really behind the scene. It's hard to see like what's happening. What I'm going to do, I'm just actually just switch back to the presentation. But before I do that, oops. I'm just going to run a system test just to show that there's more thing that work, and we'll come back to that later. Make sure that that it has the connection. I need to see some green dots before I switch. Make sure all the port forwarding are there. Okay, good. So let's go back to the presentation here. And here I'm just going to, because I'm going to do back and forth between thing here. Let's do that. So let's go to some of the highlights. I'm not going to place, there's a lot of changes in different places, but I'm just going to go through some of the highlights. So first of all, we have some new gRPC services. We have the core service. This gets implemented by the core, and that replaces the adapter request handler and the core proxy. So adapters that used to call the core proxy now will call directly that core service. And adapter service, this is a common set of APIs that will need to be implemented both by the OLT and ONU adapters. And what it means in the core, we no longer to have to call this customized request handler. We can call the method directly, and we no longer have this adapter proxy also in the core. And also I added two more services. One I call this ONU inter-adapter service. Those are specific APIs that a child adapter will have. For example, ONU indication, OMCI response, tech profile, delete tcount, delete gemport. And this, I've taken them from what exists today. We can add more, we can clarify things. For example, this OMCI response, we could potentially just have one OMCI message instead of having like, you'll see the adapter has, the OLT adapter has OMCI request and ONU has OMCI response. And the reason I left it as separate because I was looking at the ONU code and it's